Welcome back to the series of sessions on data engineering. In our last session, we discussed how to create a data lake in Microsoft Azure cloud platform. We also saw how to upload a semi-structured file like a CSV file onto the data lake. But as we mentioned in the last session, normally you will not be uploading a file from your local drive into a data lake, because if the file could have been stored in a local drive like a computer, uh, the entire processing could have been done in the personal computer itself. The utility of data lake comes only when you are dealing with large data, many times unstructured data, and streaming data. So in this session, we are going to see how we can capture the streaming data. And in this case, we'll take the example of data from sensors. Now, you can consider the data coming from a sensor like a streaming water flowing from a river. Now, what we want to do is we want to tap some of this water and bring it to a data lake. Now, how do we do that? So the water is constantly flowing through this, and we need to tap this water into a lake, just like it typically happens in a dam. What we need is essentially a pipe that will bring the data, tap the data from the lake, and it will bring and make the data flow into this data lake. Now, this is the structure that we need to follow when we are creating an environment to tap the streaming data from machines, which can be things like temperature, humidity, pressure, vibration, etc., and bring it to a data lake. And from the data lake, we will go through the ELT process by which we can use this data. But first, we need to tap this data. Now, in our example, we do not have a real sensor or a real IoT from where we get the data. So we'll get a simulated stream of data. One of the most popular IoT that are used in the industry is called Raspberry Pi. You can Google and find out how a Raspberry Pi looks like. It is like a mini computer which has the ability to capture the data through a sensor and also store the data, but the storage format is not like a database. The storage format typically is in a lower level data stream, like the storage can be something like some form of this, and each of these letters may mean, or the numbers may mean something like the first one may mean that this is indicating of temperature, and then first two letters can mean temperature, this can mean the value of the temperature, like that. It can go on. It is own format and its own syntax. Now this data needs to be captured and then put it into the data lake. And then this needs to be converted into a usable form, which can be a relational database or a non-relational database, or even it can be visualized into a tool like a Power BI. But our first job is to capture this data. So what do we need for that? We need something called an IoT hub, which will be able to talk to the device over here. So the device is capturing the streaming data, and the IoT hub should be able to talk to the data here, from the sensors, which will be able to understand this format of the data. And once that is done, then you need some kind of a query which will capture this information and push it to the data lake. And this query is done through something called a stream analytics job. This stream analytics job will push the data into the data lake, and then from the data lake, you can process the data through ELT. That's what we'll try to do over here. So let us see how this can be done. The first thing is that we need to find out a simulator for the Raspberry Pi. As I mentioned that in real scenario, you will be connecting directly to the Raspberry Pi. But here in absence of the Raspberry Pi, we'll go with a simulator, and there is a simulator which you can search with the keyword Raspberry Pi Azure IoT Online Simulator, and want to search, you will be taken to a GitHub page, and this GitHub page is nothing but a piece of code which does the job of simulating the actual data from Raspberry Pi. On the left-hand side, you can see the image of a Raspberry Pi, a representative image of a Raspberry Pi on a breadboard. And what it does is the Raspberry Pi has a sensor and has the little bit of CPU, very small CPU, and little bit of storage, which captures the data from the sensor and processes the data, but it cannot hold the data for long. It has to pass it on to a persistent storage. And that's what we want to do. We want to capture it from these sensors in the Raspberry Pi and put it into a data lake from where we can later on process it. So in order to do this, we have to go to Microsoft Azure, and we need to first create an IoT hub. The IoT hub is essentially a platform which will talk to the actual Raspberry Pi. So let us see how we can create an IoT hub and how it can talk to the Raspberry Pi. If you, since I have already worked on it before, as IoT hub appears over here, but if you are working for the first time, you might have to search over here as IoT hub, and here you will get an IoT hub, and you can select the IoT hub from here. So we'll create an IoT hub. As we mentioned that any resource that you create in Azure, we will put it under a resource group so that it is easy to manage. So here also we'll create a resource group. Every time we are doing the exercise, we are creating a resource group, because at the end of the exercise, for example, every time I'm recording this session, at the end of the session, I'm deleting the resource group so that it doesn't consume the free credits that I have. Okay, and this is also a practice that you need to ensure. Otherwise, your credit will get exhausted and you will not be able to work on your account. In other words, you will need to pay for all these resources. But if you delete the resources after your job is done, most of the exercises that we are doing in this course can be done within the $100 credit that you have. So we'll create the resource group. Again, we'll follow the same naming convention that we said, that it has to be unique. So we'll take our own name and then suffix it with a short form of what we are creating. For example, if it's a resource group, we'll just name it as RG, and that way we are fairly assured of the fact that this will be a unique name. We are going to create an IoT hub here, and we'll name it in the same way. We'll say give our own name and then say IoT. We say the region that we'll be selecting should be the region that is nearest to the users. In my case, the region that is nearest to me is Central India, and I'll select that. And it will load the various tires in the daily message limit. As you can see that there are various types of tires available. Right at this point of time, we do not want a lot of data to be captured, and we can use a free tire, which allows 8,000 messages, that means 8,000 signals per month, per day, which actually costs me no additional dollar or rupees per month. So for me, this is okay because we are just using it for the trading purpose. We'll go to the networking. We'll leave it as public access because we want all the services of Azure to access this. We can leave the permissions as is. We don't need to make any changes over here. We don't want to give any tags. But if you have a large number of IoT devices and you have to create a large number of IoT hubs, then it is a good practice to give some tags that helps you to search. But for us, we are just doing it for trading purpose. We probably will create only one IoT hub and hence no tag is needed. It will go through a validation process. If there is no errors, it should say that validation is complete and we should be able to get this create symbol through which we'll be able to create the IoT hub. Let us create the IoT hub. As you can see, it is getting created and getting deployed, just like in case of data lake, this was getting deployed. This also will get deployed very soon. So it is showing as deployment in progress. It will take probably a few seconds before it gets deployed. Let's come back after it has got deployed. As you can see, my deployment of IoT Hub is complete. I'll go to the resource now, which is the IoT Hub. I'm inside the IoT Hub. Now, first thing is that you need to ensure that this IoT Hub can recognize the signals from this Raspberry Pi. So there has to be a way by which the IoT Hub can access these signals. How do you do it? If you notice on line number 15, there is something called connection string. Now I have to replace this connection string with the connection string I have for the IoT hub. Only then this particular IoT hub will be able to access the signals generated from the IoT. How do I get the connection string? Go to the device management in the devices. First, I have to create a device which represents this particular IoT. It's coming up. Once it comes up, we have to create a device within IoT Hub that represents this particular IoT. As you can see that there can be multiple sensors in an IoT Hub, and that's what usually is when you're deploying it for a real business purpose. But for our case, we'll just add one device. So let's add this device. Let's call this device as IoT1. You can give any name if you want. And nothing else needs to be done. Everything else can be kept as default. You just save this. And now this device has been created. Now this device must retrieve the signals from this IoT simulator. If in real case it was IoT, it would have been connecting to a microcomputer in this particular Raspberry Pi. But in this case, we are going to connect to a GitHub code, which is basically simulating the signals. We'll go to this IoT1. And here you see there is something in the primary connection stream. You can view the actual code in the primary connection stream. You can see the host name equal to the name of the IoT hub and then some access keys. And all that you need to do is to copy this and paste it over here. So to remove whatever there is there as existing values and paste it with here within the quotes. So remember this quote should be there. Okay. Once you do that, IoT Hub will be able to recognize the signals from this particular simulator. Now, if I go back and start running, you will see that here it is simulating as if it is giving the signal. In a real Raspberry Pi also, you will get this LED on and off, which shows that it is transmitting the data. And here you will see some temperature and humidity values being passed on. Of course, these are simulated values, they are not actual values, but in case of a real sensor, this will be actual values. Now, these values are getting captured over here. So it takes a little bit of time to get these values captured. If we refresh it a few more times, we'll start getting the values. And after some time, you will be able to see that you are getting these values over here. You can now see that there are 34 messages that have been received from here. And this IoT device also should come to a number 1. This usually takes a little time to get updated, but very soon you will see that this IoT device number will become 1. So what has happened now is this data is now getting accepted by the IoT hub. But remember, the IoT hub cannot store the data. We need to push this data into a data lake, which means that we have to make that pipeline and bring the data into the lake. So that pipeline is the stream analytics job which we have to build, which essentially is a query that will collect the data and then push it to a data lake. We are going to see this in our next session. As of now, always remember that once you have done this, you should delete all the resources that you have created. So first is I can stop this from here. So the sample is stopped now, no longer it will pass the message. And now I can go to the resource group and delete the entire resource group. Once I delete the entire resource group, it is going to delete the IoT hub that is there inside the resource group. And so we'll just copy this over here and delete this. And that will delete the resources inside the resource group. So this way, we have seen that how we can capture a streaming data into an IoT hub in Azure. Next session, we are going to see how we can push this data into a data lake.